Hi dear students, this is the second video of Units and Measurement chapter related to the NEET Physics previous year questions. Already I was uploaded one video part 1, that is in the playlist of NEET previous questions Units and Measurement series there. So go and watch it. So this is the second video, and the question should be like this. Here there should be question given in the 2022 NEET it was given. Question is, the dimensions of M, L T inverse 2, A inverse 2 belongs to the magnetic flux, self-inductance, magnetic permeability, electric permittivity. The dimension formula of this one belongs to which among these four? That is the question. Clear? So when you have idea about the direct dimension formulas, then no problem, you can directly check it and give the correct option. But when you have no idea about that one, you can directly go to the formulas. The first thing here, magnetic flux. What we know, pi is equals to B into A. Here it is magnetic induction and this is the area. So here again what read, F is equals to IBL and B is equals to IF by IL. What is F again? Force. So I am going to write this is M. Force is dimension only what? ML T inverse 2 by I means what? Current. So you can take current for A or I, anything whatever may be. And this is now L. L means length, its dimension formula is L. Then what you get? B is equals to, here now, M, L for of 0 and A inverse 1 and T inverse 2. Or like this also. M, T inverse 2, A inverse 1. Clear? So this is what dimension formula of magnetic induction. What you have to find out actually? Flux. Pi is equals to B into B, dimension formula is what? M T inverse 2, A inverse 1 and into area means what? L square, length into breadth. Then what you have to write? M L square T inverse 2, A inverse 1. This is the dimension formula of flux. So but what he was given? M L T inverse 2, A inverse 2. Here M L square is there and A inverse 1 is there. That's why flux is wrong answer. Now next you can go for self-inductance. What it is? Self-inductance. Self-inductance, what we know, pi is proportional to I and pi is equals to L into I and L is equals to pi by I. Now what you have to write? Already magnetic flux is what it is for dimension formula? M L square T inverse 2 A inverse 1 by I. I means again current. So then what will be here? M L square T inverse 2 and A inverse 1, A inverse 1. A inverse 1 and it comes numerator like what right? A inverse 1. Then what I have right here? Self-inductance is equals to M L square T inverse 2 A inverse 2. This is the dimension formula of self-inductance. Now we can check it. Self-inductance is right or wrong. It was given M L T inverse 2 A inverse 2. Here M L square is there. Here L is there. That's why self-inductance also wrong. Now again we have to check these two. Clear? So here what is magnetic permeability and what is the electric permittivity? Here now we can check that one. So first thing here, electric permittivity I am going to explain here. F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. This epsilon naught is what? Permittivity in electric field. Then what you have to write? Epsilon naught is equals to here Q1 Q2 by F into R square. Here instead of charge what you can write? I into T I am going to write. Q is equals to IT. Or I is equals to Q by T. From that what you have to write? Q is equals to IT. IT into IT by F is what? Force. into r square. Now you can substitute the dimension formulas here. Epsilon naught. I means what? A. T means what? Time. A into T by m L force ml square m L T inverse 2 into r means distance L square. Then what, right? Epsilon naught is equals to A into A square, and T square by m L cube, L into L square, L cube, and this is what? T inverse 2. Then what right here? Epsilon naught is equals to m inverse 1, L inverse 3, and here T square is there, T to the power minus will come numerator, 10 plus 2, T plus T to the power plus 2, okay, and A square is there. Then epsilon naught is equals to m inverse 1, L to the power minus 3, T to the power 4, and A square. So now we can check it. So here electric permittivity also wrong option. Clear. Now only the thing is what it is? Magnetic permeability is there. Let's check it is whether it is right or wrong. For that we can use the formula F is equals to mu naught by 4 pi into m1 m2 by r square. Clear. What is permeability here? Mu naught. Mu naught is equals to what, right? F into r square by m1 m2 you can write. Clear. So F is ml T inverse 2 and r is length L square by what is small m? It is the pole strength. Pole strength that should be having dimension formula LA. Clear. You can take LA you can write, and LI also you can write, no problem. So ml T inverse 2 L square by LA into LA. Then what you write here? M L T inverse 2 and this is L square by L square and A square or a to the power of 2. Clear. So these two are cancelled. What you get here? M L, this is L2 and this is also L2. If it is come to numerator, what, right? L2 by L2 means what? L2 L to the power of minus 2. That means L to the power of 2 minus 2 means what? L to the power of 0. Clear. And already L is there. M L T inverse 2 and it is A squared is there. If it is comes to numerator, what do you write? M L T square A to the power of minus 2. So M L T inverse 2 A to the power of minus 2 is the dimensional formula of magnetic permeability. So third C option is the right one, children. Third option is correct one. See the next question. It was given in the 2022 also. The question should be like this: plane angle and solid angle have dash units but no dimensions, and dimensions but no units and no dimensions, both units and dimensions. Direct question. Units but no dimensions, it means that units are there but no dimensions. Second option, dimensions but no units, dimensions are there but no units. And third option, no units and no dimensions, both are not there. And fourth option, both units and dimensions, both are having the units and dimensions. So among these two, which one is the right one? So here A option is the right one. They have units and but no dimensions. This is the right one. Here plane angle has unit is radian and solid angle has units steradian. Clear. So here simply in this case d theta is equals to ds by r we are taken, and in this case here the solid angle is given by the dA by r square. You can observe here dA and this is the dA by r. This is the r value. So this is the diagram for solid angle and this is the plane angle. So what do you write? Angle means what actually? Arc for radius. Arc for radius. That's why here both are having the units. Plane angle unit is radian and solid angle unit is steradian. So they can be explained, they can be expressed in formulas like this. And next one is what? They do not have any dimension formula because both are ratios. Both are the ratio. Here ds by dr, arc by radius, both are the same quantity. and in this case also same quantity. That's why plane angle and solid angle have units but no dimensions. Why they do not have dimensions? Because they are the ratio, because of their ratio of same quantity. So this is that's why here A option is the correct one. See the next question. This question was given in the year 2021, and this is also interesting one. If E and G respectively denote energy and gravitational constant, then E by G has the dimensions of. So what he was given, E, capital E is what? Energy, and capital G is what? Gravitational constant. Then E by G has dimensions of. We want to find out the dimensions of E by G. That is the question here, and options are given: m square, L to the power of minus 2, T to the power of minus 1, and m square or m to the power of 2, L to the power of minus 1, T to the power of 0, and third option m, L inverse 1, T inverse 1, and D option m, L to the power of 0, T to the power of 0. So among these four, which is the right one, we have to find out it. So I think you have idea about the dimension formula of energy. What it is? M L square T inverse 2. And what is the universal gravitational constant dimensional formula? So if you have no idea, then directly go to the formula. F is equals to m1 m2 by r square. Then G is equals to what? F into r square by m1 m2. Then G is equals to force m L T inverse 2, and distance r means what? Distance r square means what? L square by, here m1 m2 are the masses, then m square or m to the power of 2. Then what right here? M inverse 2 L into L square, L to the power of 1 plus 2 and T to the power of minus 2. Then what you get? Here m to the power of 1 minus 2 L cube T inverse 2. That means what? M inverse 1 L cube T inverse 2. This is the dimension formula of G. Now what you want to find out? E by G. So we have to write E divided by G. What is the dimension formula of E? M L square T inverse 2 by G. M inverse 1 L cube T inverse 2. Clear? Then here we can write like this: E by G is equals to M. Clear? If it is comes to numerator, what write? M plus 1 and L square, and it is L to the power of minus 3, and T to the power of minus 2, it is there. In the denominator what you have? Minus 2. If it is comes to numerator, plus 2. Clear? That's why here what write here? M 1 plus 1 L 2 minus 3 T minus 2 plus 2. Then what do you get here, children? So this is m square L to the power of minus 1 and T to the power of 0. Then what did here? M square and L to the power of minus 1 and T to the power of 0. So now we can check the options. So among these four, B is the correct one. Look here, m square L inverse 1 T to the power of 0, m square L to the power of minus 1 T to the power of 0. That's why B is the right answer. This question, it was given in the year 2020. Dimensions of stress are very easy question. Dimensions of stress are, options are given: m L T inverse 2, m L square T inverse 2, m L to the power of 0 T inverse 2, m L inverse 1 T inverse 2. So that is the option. Those are the options. So what do we know? Stress formula is what? Stress is equals to what do we know? Force per area. Force per area. So already force is equals to what we know? Force is equals to m into A. What is A? Acceleration. What is m? Mass. That's why it has dimension formula is m L T inverse 2. And now area, length into breadth. What we write simply here? L. That is what? L to the power of 1 plus 1. That means what? L square. Now we can substitute those in that formula. Stress is equals to force m L T inverse 2 by L square. Here now what do you write? M L. If this comes to numerator, what do you write? L to the power of minus 2, T to the power of minus 2. Then M, when base are equal, what you have to add? Exponents must be added. So 1 minus 2 and T inverse 2. Then what it is? M L inverse 1, T inverse 2. So this is the dimension formula of stress. So now we can check the options. M L T inverse 2, it is wrong. Next one is M L square T inverse 2, it is wrong. And this is also wrong. Finally, option D is the correct one. Clear? This is the next question, and it was given in the 2013. The pair of quantities having same dimensions is. The pair of quantities having same dimensions is. Some quantities are given, among them which are having same dimensions, we have to find out it. Some options are given. First option is impulse and surface tension. Second option is angular momentum and work. Third option is work and torque. And fourth option is Young's modulus and energy. So these are the four options. We have to find out which are the correct one. So first thing we have to check impulse and surface tension. So impulse, what do you write? Simply here force into time. Then impulse is equals to dimension formula of force is what? M L T inverse 2 into T. T means time. That is what? Here T. So M L T inverse 2 plus 1. That is what? Here M L T inverse 1. That is the dimension formula of impulse. Now surface tension. What it is? Force per length. Force per length. What is force? M L T inverse 2 by L. So then what you get here? Obviously surface tension is equals to M to the power of L 1 minus 1 T to the power of minus 2. That means what we get here? M L to the power of 0 T inverse 2. So now you can check the impulse dimension formula and surface tension dimension formula. Both are not same. That's why here impulse and surface tension option A is the wrong one. Clear? And next one we can check angular momentum and work. Angular momentum and work. Second option we have to check angular momentum. L is equals to what did formula? mvr. M means mass, capital M, and V means what? Velocity, LD inverse 1, and R means what? Distance. Here L. What do you get? M L square T inverse 1. This is the dimension formula of angular momentum. Next, work. What is the work here? F into S. M L T inverse 2 into distance, that is L. So M L square T inverse 2. So we can check the dimension formulas of now work and angular momentum. Angular momentum is M L square T inverse 1 and M L square T inverse 2. So both are not same. That's why B option also wrong one. And now you can check the now here. You can check the option D now. So what is the option D here? Young's modulus and energy. What is Young's modulus? Y is equals to longitudinal stress by longitudinal strain. Obviously it is quite similar to stress versus strain. So here Y is equals to here stress means what? Force per area by strain means change in length by original length. Clear? Then obviously strain is a dimensionless quantity. That's why here Y has the same dimensions of stress. So that is what? F by A. Then what right here? Y is equals to M L T inverse 2 by L square. Then what do you get here? M L for 1, L for minus 2, T inverse 2. Then what do you get? M L inverse 1, 1 minus 2, minus 1, and T to the power of minus 2. This is the dimension formula for Young's modulus. And obviously what we have? Energy. It is well known thing for us. What is M L square T inverse 2. So this is the energy and this is the Young's modulus. You can observe now here both are not equal, not same. That's why here D option is the wrong one. So the correct one is what now here? Work and torque is the correct one. Further also we have to check it whether it is right or wrong. Again we have to check it now. So when we have idea about the dimensional formulas directly, the time will be very safe. Here now work. What is M L square T inverse 2. And torque, what it is? Torque tau is equals to R cross F. So here F means what? M L T inverse 2 force. Dimensional formula is ML T inverse 2 and R is the L. Then what is here? L to the power of 1 plus 1 and T to the power of minus 2. Therefore ML square T inverse 2. So here work dimension formula is this one and torque is this one. You can observe these two, then you can easily identify that C is the right answer. Why? Because both are having the same dimensional formula. You have to remember work and torque both are having the same dimensional formula. This is one of the important and logical question. It was given in the mains 2012 and NEET 2011. So that's why I watch very carefully here. The dimensions of mu naught epsilon naught of whole to the power of minus 1 by 2 are the dimensions of mu naught epsilon naught whole to the power of minus 1 by 2 are. Options are given: L to the power of 1 by 2, T to the power of minus 1 by 2, LD inverse 1, L inverse T, and L to the power of 1 by 2, T to the power of 1 by 2. The dimensions of mu naught and epsilon naught. What is mu naught? Here permeability of free space. And what is epsilon naught? Permittivity of free space. So here no need to substitute the dimension form of these two, that one. Simply we have one relation is there, that is the velocity of light. C is equals to 1 by under root of mu naught epsilon naught. So this is the relation between the permeability and permittivity and velocity of light. So that's why here what was given, mu naught epsilon naught whole to the power of minus 1 by 2 means what? Here x to the power of minus 1 it is there. How we can write 1 by x like that? Like that here mu naught epsilon naught whole to the power of minus 1 by 2 also written as here like this. Here that is equals to 1 by mu naught epsilon naught whole to the power of 1 by 2 we can write, and that should be again written as like this. That's why here C is equals to 1 by under of mu naught epsilon naught. So now here what we know, according to principle of homogeneity, in any dimensional equation, the dimensions of the left side physical quantity should be same as the dimensions on the right side. That's why dimensions of LHS must be equal to the dimensions of RHS. That's why here its dimensional formula is same as C. C is what? Velocity of light. Velocity of light, how we can write? LD inverse 1. That's why you can check it now here. Among the four options, C option is the right one. LT inverse 1. Clear? Next question, it was given in the 2010. The dimensions of epsilon naught E square. The dimensions of epsilon naught E square, where epsilon naught is the permittivity of free space and E is the electric field, is the dimensions of what you have to find out. We want to find out the dimensions of epsilon naught E square. So options are given: M L square T inverse 2, M L inverse 1 T inverse 2, M L square T inverse 1 and M L T inverse 1. So among the four options, which is the correct one, we have to decide that. Clear? So here we have formula, it is there, energy density of electric field. energy density of electric field, that should be written like UE is equals to of epsilon naught E square. This is the formula. Energy density of electric field, what? UE is equals to of epsilon naught E square. So according to the principle of homogeneity, both are having the same dimensional formulas. That's why here simply now energy density can be written as here energy for volume. That is the formula here. Energy density is equal to energy for volume. Then obviously what we get, energy for energy, what you know, ml square T inverse 2 by volume is what is L cube. So now what you can write, m L square, and L to the power of it is now minus 3 T inverse 2. Then what did here, m 2 minus 3 T inverse 2. It means that 2 minus 3 means what? Minus 1. Therefore m L inverse 1 T inverse 2. So this is the dimensional formula of energy density, and that should be dimensional formula of epsilon naught E square. That's why here among the 4 options, B option is the correct one. M L inverse 1 T inverse 2. M L inverse 1 T inverse 2. So B option is the right one. See the next question. This is the another model and important one, and was given in the 2009. The question should be like this: if the dimensions of a physical quantity are given by m to the power of a, L to the power of b, and t to the power of c, then the physical quantity will be, the dimensions of a physical quantity are given by, one dimension formula is given like this. What it is? M to the power of a and L to the power of b and t to the power of c. Clear? Then the physical quantity will be, here 4 options are given. If a is equals to 1, b is equals to 0, c is equals to minus 1. If you can substitute these dimensions, then it is velocity. We have to check this is the right or wrong. Next, if you can substitute a is equals to 1, b is equals to 1, c is equals to minus 2 in that formula, if it is acceleration. Again we have to check. And now force. If a is equals to 0, b is equals to minus 1, and c is equals to minus 2. If you can substitute these 3 in that formula, it may give force or not. And now 4th option, pressure. When in that formula, if a is equals to 1, b is equals to minus 1, and c is equals to minus 2. If you can substitute these values, then we will get pressure or not. Let's check one by one. Here now, the first one is what? A is equals to 1, b is equals to 0, and c is equals to minus 1. We have to check. The first one is what? A to a value is 1, and b value is what? 0, and t value is what? Minus 1. That means what? M L to the power of 0 T inverse 1. So it is the dimension formula of force or, sorry, what it is? Velocity. Dimension formula of velocity or not, we have to check. Clear? So what is the dimension formula of velocity actually? Velocity is equals to what to write? Displacement by time. That means what? L by t. Velocity dimension formula is what? LT inverse 1. LT inverse 1. But what we got here? MT inverse 1 we got. That's why when we can substitute a is equals to 1, b is equals to 0, c is equals to minus 1, we are not getting the physical quantity of dimension formula. What it is here? Velocity. So option A is wrong. So option A is the wrong one. And similarly, you can check here now option B. A is equals to 1, B is equals to 1, C is equals to minus 2. M to the power of A means what? 1. And L to the power of B, that is what? 1. And C T to the power of C minus 2. So M L T inverse 2. So what was given? It is acceleration. So A is not equals to M L T inverse 2. Why? Because this one is nothing but force. And A is equals to what? LT to LT inverse is the right one. But what you got here? M, L, T inverse 2. That's why here second option also wrong 1. Clear? After substituting the A is equals 1, B is equals 1, C is equals minus 2, we are not getting the dimension formula of acceleration. That's why second option is wrong. And third one, what it is? We can go for now. Third one. Here A is equals 1, M to the power of 1, and L to the power of minus 1, and C to the power of T to the power of minus 2, T to the power of minus 2. So M, L inverse 1, T inverse 2. That is force or not? We have to check. It is not force. Clear? It does not use the force. F is not equals to here M, L inverse 1, T inverse 2. Clear? Why? Because for force dimension formula is what? M, L, T inverse 2. But what we are getting here? L to the power of minus 1 we are getting. That's why here after substituting the A is equals 0, B is equals minus 1, C is equals minus 2, we are not getting the force. So option C also wrong. The correct one is what here now? A is equals 1, B is equals minus 1, and C is equals to minus 2. Then what we get? We will get pressure. Let us check whether it is right or wrong. Again we have to check that one. Clear? So now option D. What is option D? Here M to the power of 1 and L to the power of minus 1 and T to the power of minus 2. You have to check it. So what is pressure? Force per area. That is what? M, L, T inverse 2 by L square. Then what it obviously? M, L minus 2, T inverse 2. Then what you get? Here P, L to the power of minus 1, T inverse minus 2. That's why here after substituting the A is equals 1, B is equals minus 1, C is equals minus 2, in that formula or in the dimension formula, the dimension formula what are you reading? Dimension formula of pressure. That's why option D is the correct one. Clear? See the next question. This is the another model and interesting and so confucius. Look here. Which of the following 5 physical parameters have the same dimensions? So which of the following 5 physical parameters have the same dimensions? Those are energy density, refractive index, dielectric constant, Young's modulus, and magnetic field. So he was given 5 physical quantities. Among them, which are having the same dimensions? That is the question. It was given in the 2008. So options are given 1 and 4. 1 and 4 means what? Energy density or Young's modulus. B, second option, 1 and 5, energy density or magnetic field. And third option, here now, 2 and 4, 2 and 4, 2 and 4, refractive index and Young's modulus. And D, 3 and 5, 3 and 5. So what is dielectric constant and magnetic field? So look here now. You have to check whether they have same dimension formula or not. Actually, among the 5, refractive index and dielectric constant both are the dimensionless quantities because both are the ratios. That's why if you can give like 2 and 3, now you can go for 2 and 3 is the right answer. But he was not given 2 and 3 combination. He was given different combination here. So first thing is energy density. What is energy density? So energy density, what we write? UE is equals to what we write? Energy for volume. Energy for volume. So what it is? ML T inverse ml square T inverse 2 by volume is what? LQ. Then what you get here? M L to the power of minus 3 T minus 2. That means what? M L inverse 1 and T inverse 2. Clear? And next, fourth one. 2 and 3 has no dimension formulas. That's why I am going to the fourth one. What is Young's modulus? Longitudinal stress by longitudinal strain. Clear? So longitudinal stress is what? F by A by change in length by original length. It is the dimensionless quantity. Directly you can write F by A. So Young's modulus is what? F means what? Force. M L T inverse 2 by area is L square. Then what you get? M L inverse 1 and T inverse 2. So 1 and 4 has the same dimensional formula. So 1 and 4. So A, option A is the correct one. So let us check here. 1 and 4 is the right one, and 1 and 5. We have to check this combination also. 2 and 4 do not have this same combination because it is dimensionless and it is having some instrument. What it is? This one. That's why C is the directly wrong one. And 3 and 5 also same thing here. Now we can check the 1 and 5. And as you can see what it is, M L is 1, T inverse 2. And magnetic field, F is equals to IBL and B is equals to F by IL. So it is totally different. Here for force what is M L T inverse 2 by current means what? A, and L is what? Length. Then what you get? M T inverse 2 A inverse 1. This is the minus 2, and this is the dimension form of magnetic field. That's why here 1 and 5 also are wrong. So the right one is here. First option A is the right one. See the next question. It was given in 2007. Dimensions of resistance in an electric circuit in terms of dimensions of mass M, of length L, of time T, and of current I would be. So dimensions of resistance in electric circuit. What you have to find out now? Dimensions of resistance, but it must be in the form of dimensions of mass, length, time, and current I. So would be options are given: M L square T inverse 2, M L square T inverse 1, I inverse 1, M L square T inverse 3, I inverse 2, and M L square T inverse 3, I inverse 1. So that is the options, children, here. Now what do we know Ohm's law? V is equals to IR. And what is R? R is equals to V by I. So by using this relation we have to find out the dimensional formula. Again what we children? V is equals to what you have to write? W by Q we can write. W by Q we can write. So then V is equals to, W means what? Work. M L square T inverse 2 by, here I am going to write W is equal to, V is equal to W by Q means what? I into T. I into T. I means here current. So I already told you can represent current I R A. What will be here? I of here T means T. That means what? M L square T inverse 2 by I T. That means what here? T inverse 1 and I inverse 1. Then what here V is equals to M L square T inverse minus 2 minus 1 minus 3 and I inverse 1. So this is for potential, and R is equals to what? V by I. So R is equals to what is V? M L square T inverse 3 I inverse 1, T inverse 3 I inverse 1 by I means what? Current. Then R is equals to M L inverse 3 inverse L square T inverse 3 and I inverse 1 and I inverse 1. Then R is equals to what? M L square T inverse 3 minus 1 minus 1 minus 2. So it is also expressed like this also. M L square T inverse 3 and A inverse 2 also you can write, no problem. But in the options ID is there. That's why you have to write M L square T inverse 3 I inverse 2. I inverse 2. Here A is the completely wrong one, and I mean it is not related to any particular kind of dimension formula of R. But here the confusion is among these three. Here M L square T inverse 1 I inverse 1, it is the wrong. But in T inverse 3 2 there. Again up to 3 quantities both are all are same. M L square T inverse 3 common. But what is the difference here? Last one. That's why while we are doing the substitution and getting the dimension formula, you have to carefully do that one. So that's why here according to this one, option C is the right one. See the next question. It was given in 2005. The ratio of the dimensions of Planck's constant and the moment of inertia is the dimension of. The ratio, it was given the ratio of Planck's constant and moment of inertia. So if we can substitute the Planck's constant by moment of inertia I, then we will get the dimension formula. Among those, here time, frequency, angular momentum and velocity. The dimension of h by E, Planck's constant, and moment of inertia, that should be equals to the one of these. Now what you have to find out, that is we have to find. So h by E is equals to one of the dimension of these four quantities. So first thing is you have to find out the dimensions of Planck's constant. Now here E is equals to h nu, then h is equals to what? E by nu. Here what is h? Planck's constant. What is E? Energy. What is frequency? S. Nu is what? Frequency. Then E means what? M L square T inverse 2 by frequency is what? Nu is equals to 1 by T. That means what? T inverse. Then what you get? H is equals to M L square T inverse 2 and T. If it is comes to numerator, what right? T. Then what you get here? H is equals to M L square T inverse 1. That is the dimension formula of Planck's constant. Next thing is what? I. I means what? Moment of inertia. Moment of inertia here, mass into mr square. Formula y is equals to mr square is there. That's why here m into r means distance ml square. Ml square is the dimension formula of moment of inertia. Now we can write h by I, then ml square T inverse 1 by, here now ml square we have ml square. So then obviously what you get here? M to the power of 0, L to the power of 0 and T inverse 1 we will get. So what we will simply get, right? M to the power of 1 minus 1 and L to the power of 2 minus 2 and T to the power of minus 1. What do you get? M to the power of 0, L to the power of 0, T inverse 1. That means what is simply the ratio of these two what is? T inverse 1. T inverse 1. Just now only I told you what is nu is equals 1 by T, that is equals to what? T inverse. T inverse is here what? Dimension formula of frequency. That's why here time, frequency, angular momentum and velocity, among these the ratio of Planck's constant and moment of inertia gives what? Dimension formula of frequency. That's why B option is the correct one. See this question, children. Here it was repeated in 2004 and 1992. The question is very simple one, you know. The dimensions of universal gravitational constant are, options are, options are given. M inverse 1, L cube, T inverse 2 is the first option. M L square, T inverse 1, second option. M inverse 2, L cube, T inverse 2, and third option, last fourth one is M inverse 2, L square, T inverse 1. These are the options. So what do you find out? Universal gravitational constant. So what do we know? Universal law of gravitation, F is equals to G into M1 M2 by R square. From that what write? G is equals to F into R square by M1 M2 we can write. So here what is F? F is the force. For the dimension formula what is? ML T inverse 2. And R is what? Distance. R square means what? L square. And M1 M2 are what? Masses. So M. So then what you get here, children? M L to the power of 1 plus 2 L square and T to the power of minus 2 by M square. M to the power of 2. Then G is equals to what, right? M to the power of minus 2 L cube T inverse 2. So here what, right? M 1 to the power of 1 minus 2 L cube and T inverse 2. Then what are here? M inverse 1 L cube and T inverse 2. T inverse 2. Clear? That's why among the four options you have to check it. M minus 1 L cube T inverse 2. A option is the right one, remaining all are wrong. See the next question. It was given in 2001. The dimensions of Planck's constant equals to the that of, the dimensions of Planck's constant equals to that of energy, momentum, angular momentum, power. Planck's constant dimension must be equals to any one of these. That is, we have to find out. First, we have to know about the dimension formula of Planck's constant. So E is equals to h nu, and h is equals to what? E by nu. And what you know, ml square energy, ml square T inverse 2 by it is T inverse 1. Then what you get? ml square T inverse 1. So this is dimension formula of Planck's constant. H is equals to what? ml square T inverse 1. So if it is equals to any one of the dimension formula, then what is that one? That is, we are going to discuss here. The first thing is A. A is what? Energy, ml square T inverse 2. So these two are not same. That's why energy is wrong answer. Next, momentum. B. What is momentum? Mass into velocity. Mass into velocity. For mass, capital M, velocity LT inverse 1. So you can compare these two. So these two are not same. B also wrong one. Next, D. Power. P is equals to what? W by T. What is W? Work. Dimension formula is what? ml square T inverse 2 by time T. Then what is ml square T inverse 3? ml square T inverse 3. So you can compare it now. It's the wrong one. So D also wrong one. So the final answer is what is? Angular momentum is right answer. Let's check it now. L is equals to mvr. What is L? Angular momentum. What is m? Mass. What is v? Velocity. And what is r? Distance. Then what at m is capital M, and v is LT inverse 1, and for distance is L to the power of 1 plus 1. Then ml square T inverse 1. So that's why here third option is the correct one. H and L both are having the same dimensional formula. Clear? The next question, it was given in the year 2000. The question is, which pair do not have equal dimensions? He was not asking which are having same. Which pair do not have equal dimensions? So some combinations are given. Among them, one pair have no same dimensions. Which is that one? First, he was given energy and torque, force and impulse, angular momentum and Planck's constant, and fourth one is the velocity and already once again. Angular momentum, Planck's constant, and D is the elastic modulus and pressure. Elastic modulus and pressure. Elastic modulus and pressure. Elastic modulus and pressure. So among these combination which is having the no equal dimensions, that is the B option is the correct one. Remaining all are same. Let's check four options. No need to worry. We will check the four. First one is A. Energy. Dimension formula is ml square T inverse 2. And torque, R into F. R means distance and F means what? Force. ml T inverse 2 is its dimension formula. Then what you get? Torque is equals to ml square T inverse 2. That's why E and T are have same dimension formula. That's why A option is the wrong one. And now C. Angular momentum. L is equals to mvr. So M means mass, V means velocity LT inverse 1, and R is L. So ml square T inverse 1. And C now, Planck's constant. E is equals to h nu. Then h is equals to what? E by nu. So ml square T inverse 2 by T inverse 1. That means what? ml square T inverse 1. So these are have equal dimensions. That's why C also wrong. And D1 is what? Elastic modulus and pressure. So elastic modulus means stress by strain. stress by strain, that is what elastic modulus. So already strain is dimensionless quantity, then modulate stress is what? Force per area. So ml T inverse 2 by L square. Then what you get? M L inverse 1 T inverse 2. So here force per area is what we call pressure. So therefore pressure also having same dimension formula. So that's why here A, C, D all have same dimensional formulas. That's why here it is also wrong, because it was asked do not have same dimensions. So now force and impulse both are having the same dimensional formula. Look here, force, what is M L T inverse 2? What is impulse? Force into time, force into time. So F dot T. What is here force means? M L T inverse 2 into here T means time. Then what you here? M L T inverse 1. M L square T inverse 1, and this is M L T inverse 2. That's why here this is the right one. Here, see the next question. It is a direct bit and very easiest one. And this question was given in 1996. The dimensions of impulse are equal to that of. The dimensions of impulse are equal to that of. So dimensions of impulse must be equal to the any one of these four physical quantities. The first one is what is given? Pressure, and next one is what is given? Linear momentum, and next one is what is given? Force, and next one is what? Angular momentum. So among those four, one is have equal dimensions to the impulse. So children, already we know that what is I is equals to m of v minus u. So this is the formula we have. What it is? Impulse can causes change in momentum of the body. So what is impulse? Large amount of force acting on a body, small interval of time, what is called impulse. Impulse can cause the change in momentum. Then according to the principle of homogeneity, it is a dimensional. If you can feel that it is an equation, in that equation on both sides physical quantities have same dimensions. That's why the impulse has same dimensions of momentum. That's why here B is the right one. Here you have to remember what is I. Let us check here what is force into time. That is what? M L T inverse 2 into T. Then what you get? M L T inverse 1. This is the dimension formula of impulse. And momentum, what is? Linear momentum, mass into velocity. For mass M and velocity L T inverse 1. That's why here I and both are having the same dimensional formula. That's why B option is the correct one. See the next question. It was given in the 1995. The dimensions of RC is. The dimension of RC, R means resistance, C means capacitance. The product of these two is equals to what? Square of time. Square of time means what? T square. And square of inverse time means what? T to the power of minus 2. And the time T, and inverse time T inverse. So the dimension of RC is among these four is equals to 1. Clear? RC must be equals to among these one should be equal. What it is? We have to find out it now. So first thing is here what is R and what is C. We have to remember the dimension formulas here now. The first thing is I am going to say that here C. What is C? Capacitance. C is equals to Q by V. Again C is equals to Q means V means what? W by Q. Then C is equals to what? Q square by W. C is equals to what? Q square by W. C means capacitance. Q means what? IT all square by W. Then C is equals to I square T square by W. Here C is what? Capacitance. I is what? Current. Then I square T square means what? Time. T square by W means what? M L square T inverse 2. Then what will here? M inverse 1 L to the power of minus 2 and T square M. Look here m inverse 1, L to the power of minus 2, and I t to the power of 2 and t to the power of plus 2, and I square. Then what you get? I or a, you can write anything. M inverse 1, L to the power of minus 2, t to the power of 4, a, or you can write a also, you can write a square. No problem. Or you can use I or a, anything or maybe here. Okay, this is the dimension form of C. Then what about the R? R is equals to what? V by I. V is equals to IR, and that R is equals to V by I. What is V? W by Q. What is W? W by I into T. Here what is W? M L square T inverse 2 by I means current A, and T is the here time. Then what you get here? M L square T inverse 3 A inverse 1. Just now I told you A can equals to I, can use any one of them. By here what is M L square T inverse 3 A inverse 1, and R means what? V by I. That means here again I means what? You can write A. Then M L square T inverse 3 A inverse 2. A inverse 2. This is the R. Clear? Then substitute now here. What it is? R into C. R into C. We have it is there. So here R into C. What is R value? M L square T inverse 3 A inverse 2 into what is C value? M inverse 1 L to the power of minus 2 T to the power of 4 A square. Then you can write R is equals to here M to the power of 1 is there, here minus 1 is there, and L to the power of 2 is there, minus 2 is there, T to the power of minus 3 is there, and T to the power of 4 is there, and again A to the power of minus 2 is there, A to the power of 2 is there here. Then what you get here? R is equals to M to the power of 0, L to the power of 0, T to the power of 1, A to the power of 0. Therefore what you get here? RC. Here RC is equals to what you get here? Simply tan. That's why here C option the right one. See the next question. It was given in the 1994 and 1990. Very easiest first question. Which of the following has the dimensions of pressure? Pressure dimensions what? So that is the question simply here. Dimensions of pressure, we have to find out them among these four. ML T inverse 2, ML inverse 1 T inverse 2, ML inverse 2 T inverse 2, M inverse 1 and L inverse 1. Okay, simple, very simple. Pressure is equals force per area. Then P is equals to M L T inverse 2 is the dimension formula of force per area L square. Then P is equals to what? M L L to the power of minus 2 T to the power of minus 2. Here what you have to write? L base are equal, we have added the exponents 1 minus 2 and T to the power of minus 2. Then what is M L inverse 1 T inverse 2. So that's why here among the four options M L is 1 T inverse 2, where it is there? S B is there. That's why B option is the correct one. See the next question. This is one of the important one. It was given in 1989. This is a new model, another model. Of the following quantities, which one has dimensions different from the remaining three? Of the following quantities, which one has dimensions different from the remaining three? That means here four quantities are given. In that three are same, one is different. The different quantity is what? We have to find out that. So here first one is energy per unit volume, second one is force per unit area, and third one is product of voltage and charge per unit volume, and fourth one angular momentum. So first thing is here A, energy for unit volume, energy for unit volume, energy for unit volume. Energy is what? M L square T inverse 2 by volume means L cube. That means what you get? M L square L to the power of minus 3 T to the power of minus 2. Then what you get here? E by V is equals to M L inverse 1 and T inverse 2. So that is what E by V dimensional formula. And next, second one, what is force per area? Force per area is nothing but pressure. So M L T inverse 2 by L square. That is what M L inverse 1 T inverse 2. So here F by A also same as energy for volume. Same here. And now here third one, what is charge for unit volume? Product of voltage and charge for unit volume. So voltage means potential into charge for unit volume. Charge for unit volume. So here this is the small v and this is the capital V. Capital V is the potential, small v is the volume. Clear? So here I am going to write now V means what? W by Q. W by Q. V is what? Potential, voltage. V is equals to W by Q into Q by V. Q by V. Here Q cancel. Then what you get? That is now what you have, W by V. What is W? M L square T inverse 2 by, your volume is what? L cube. Then means what you get? M L 2 minus 3. L to the power of 2 minus 3 and T inverse 2. Then what you get? W by V is equals to what? M L inverse 1 T inverse 2. So obviously here E by V, F by A and V into Q by V all are having same dimensional formula. Same dimensional formula. So A, B, C, 3 are same. Then what is different now here? Angular momentum. So option D is the right answer. Let us check whether it is right or wrong. D is what? Angular momentum. MVR. M for mass capital M. V is LT inverse 1 and R means what? L. So M L square T inverse 1. This is the dimensional formula of angular momentum. So you can observe here A is this one, for B this one and C this one. All are same, but D is ML square T inverse 1. That's why D option is the correct one, children. So dear friends, this is enough for this video. I think so. If you can understood about my explanation, if you can satisfied about my explanation and my video, please give a comment and like, share my video and subscribe my channel, and please refer my channel to your friends also. Clear? So if you can encourage this kind of videos, I will upload more videos that will give more energy to me. Okay, thank you for watching.